All right. Good morning, Moneric.
Hello, sir.
How are you?
I'm good, sir. I'm good. How about you, sir?
I'm good. Moneric, you are studying computer science, right?
Yes, sir. I'm doing computer science.
So now in October or November, you will start your third year or fourth year?
I will begin my fourth year with the next semester.
Oh, so that's your last year. 1 year left.
Yes, sir.
I see. So besides this linear algebra, are you taking any course right now? I mean, these days?
No, sir. Only linear algebra for this summer.
Okay, very good. So that's your last year, then somehow you need to pass this course, right?
Yes. In order to graduate, I need to get this course.
Yeah. Did you already actually choose a project or not yet?
Not yet, sir. I'll do it today.
You'll do it today. Okay, good. Don't be late because people are delaying. Late, it may be late, and again, you may be in trouble. So just do it and submit it and get your good grades and enjoy your last year. As you see now, this is an online course and it's not so hard, and you are taking only one course. So but if you just delay everything, because we don't have much time, we're just covering everything in only like 6 weeks. So you have to do everything in time. Otherwise, everything is accumulating. You may be in trouble. So I suggest you to submit your assignment on time and also do your project in time. And after that, try to do well in your quizzes. And I think that will be enough. Okay, then let's uh, start. Moneric, is it okay that you cannot see me on the screen? Because when I actually share, also turn the video on and we have pictures on the right hand side, sometimes covering the screen. That's why I just keep it off.
It's okay, sir.
Okay, and after all, you have experience, you know what we're going to study here. And also, if something is not clear, we have a lot of videos on YouTube, or anytime you can just write it to me. We can discuss one more time. Anyway, in this chapter, we were talking about matrices, and in 3.1, we talk about matrix operations like addition of matrices, subtraction of matrices, multiplying a matrix by a real number, multiplying two matrices together, and their properties, right? And after in the last session, we studied the inverse of a matrix in general, right? And we use, or is it Gaussian elimination, right? And to find the inverse of a matrix. That was actually, what is it, Gauss-Jordan methods for computing the inverse. And we did like two examples there, and I left two examples for you. Today, we will talk about another, what is this thing on matrices, that is LU factorization. It's like factorizing a matrix, but in a special way, in a special case. So that is LU factorization. So let's start with this. Actually, you will see that when we consider a system of linear equations of the form ax equals b, as you see here most of the time, we are just talking about that thing, a times x equals b. In some different ways we can solve this system, right? This Gaussian method, elimination method, Gauss-Jordan methods, and after that, if this A is invertible, actually we can just multiply both sides by the inverse of A, and also in this way we can solve this. Anyway, now here we will going to consider another method here, and in different methods we are going to solve this matrix. That's also actually it's good to write an algorithm in a computer for this system. Okay, so our idea is soon you actually will see that here this a, we will try to write this, I mean the what is it, factorize this a in a special form. We call this LU factorization. LU x is equal to b. And after that, we'll just label this by something else, and we'll just keep actually solving the system. And you will see that it's much easier way comparing to other methods. Anyway, before we talk about this, first let's get some intuition about LU factorization. And we know that matrix A, it can be factorized in many different ways, right? Last time also we studied how to write matrix A as a product of elementary matrices. That is one way of factorizing a matrix. And then a lot of different ways actually we can factorize A, but here we're going to consider a special case. For example, let's say if we look at this matrix whose entries are 3, -1, and 9, -5. And here it is written as a product of two matrices. Let's say this one is matrix A. Let's just label this one by L, and this one is U. Now there is a reason why am I using this L and this one is U. Because as you see here, if you just draw the diagonal here, all the entries in the main diagonal are 1. And above the diagonal, all the entries are 0. Actually here only 1. So that's why we call such matrices lower, what is it? Unit lower triangular matrix. Unit because all the entries are here, unit, and lower because below the diagonal, the entries are, maybe some of them are non-zero, maybe all of them are non-zero. And above this diagonal, it is 0. And how about this one? We call this upper triangular matrix, because if you draw the line here, I'm not using unit here because the diagonals, the entries in the main diagonal, they don't have to be 1. It can be anything. So we just call this upper triangular matrix. Why? Because when you just draw a line through this, the first row and the last column and the main diagonal, we just draw a triangle. That's why it's called triangular. And upper means upper the main diagonal. Actually, the entries are non-zero entries. Below the main diagonal is equal to 0. So that is actually, we call, if we factorize A in this way, we call that this one is LU factorization of A. Another example, I'm not just going to show this in detail how we did this, soon actually we will see that. Here is 2, 3, 1, 5, that one is 4 by 4 matrix, that's why that is our matrix A, and this one is matrix L, let's say U. Again, if you notice here, this A, unit lower triangular matrix. All the entries in the main diagonal, they are 1s, right? And above this diagonal, all the entries are 0, 0, 0, 0, 0, 0. All the entries are 0. And that's why we call this only in the lower part. We have some non-zero, or maybe all are non-zero entries here. And how about the second matrix? Here we have, as you see here, if you just draw the main diagonal here, all the entries below the main diagonal, they are zeros. And above this, they are non-zeros. So actually, we are just calling, as you see, we just name it as lower and upper triangular matrix. Let me just do this here. Okay. So how actually we are doing this thing? So actually, we'll give a definition. One that's special matrices. Anyway, so now we have some idea actually about lower unit lower triangular matrix and upper triangular matrix. Now to do this one, for example, how can I actually write this A as a product of this L and U? That is unit lower triangular matrix and upper triangular matrix. Now just actually, since it is clear, I'll just now call this L and U. Okay. When we say L, we mean unit lower triangular matrix. When we just say U, that is upper triangular matrix. Okay. First, actually, I will just transform this into U by applying a bunch of elementary row operations. Okay. So the first one is, for example, here, how can I actually make all the entries under this 2 and -1 here, we make them 0. Okay. The first one is I should multiply, right, the first entry by -2 and add it to the second row. That is, the first one is R2 minus 2 times R1. If you do so, here we will have, here we have 2, 1, 3, -2 times 2 is -4 plus 4, that's equal to 0. Negative 2 times 1, negative 2 plus negative 1, that is negative 3. Negative 2 times 3, negative 6 plus 3, it is negative 3. And how about here? I should just add the first row to the third row. So here we have R3 plus R1. So 2 plus negative 2, that's equal to 0. 1 plus 5, that's equal to 6. 3 plus 5, that's equal to 8. Now, next one, if I just multiply the second row by 2 and add it to the third row, that is R3 plus 2 times R2, right? Multiplied by 2 and add it to the third row. Then here we will have 2, 1, 3, 0, negative 3, negative 3, and here we have 0. Negative 6 plus 6, that's equal to 0. Negative 6 plus 8, that's equal to 2. Actually, what is this? It's just upper triangular matrix because under the main diagonal, all entries are 0. Let me just denote this by U. And we know that applying elementary row operation on the rows of the matrix is just the same as multiplying this A by the corresponding elementary matrix. Let's say the first one is E1, this one is E2, the third one is E3. That means that how did we obtain this U? We obtain this U by these elementary operations. If I just write here, okay, here we have E sub 3 times E sub 2 times E sub 1, and here we have A that's equal to U. And now how can I get this A? Because here I'm trying to write A as a product of lower and upper triangular matrices. So here I should just multiply both by the inverse of this matrix. Then A will be equal to E3, E2, E1 inverse, and here we have U, and which is equal to, we know how to expand this, that's equal to E1 inverse, E2 inverse, E3 inverse. Now we know how to actually write their inverses, right? And I can just write it again. This here we have E1 inverse, E2 inverse, E3 inverse. What is this? E1 inverse, here we have 3 by 3 matrix, times E2 inverse, also here we have 3 by 3 matrix, and E3 inverse, also here we have this. And if I just multiply this, we will get lower triangular matrix. And what is E1 inverse? As see here, we should multiply the first row by 2, right? Negative 2, and add it to the second row. So that means that here we will have 1, 0, 0. So here we have negative 2, 1, 0, 0, 0, 1. And how about the second one? We should multiply the first row by 1 and add it to the third row. So here we will have 1, 0, 0, 0, 1, 0. So we should multiply the first row by 1 and add it to the third row. So here we will have 1, 0, 1. And how about the last elementary row operation? Its inverse will be, we should multiply the second row by 2 and add it to the third row. So its inverse will be, I should multiply this by, no, here that will be no 2, right? And here it is plus, so this should be minus. Okay, this should be, okay, here, because we're talking about the inverse. Okay. And the last one, it will be, we should multiply by 2. So to find the inverse, we should multiply by negative 2, the second row by negative 2, and add it to the third row. So here we will have 1, 0, 0, 0, 1, 0. If we multiply this by negative 2 and add here, here we will have 0, negative 2, and here we have 1, right? That is actually our elementary, matrices. So if you multiply them together, you know how to multiply these things together. Let me just write the answer here. Okay, multiply these 3 matrices together. Here we will have 1, and we know that's actually the answer because here, if you notice here, all the entries above the main diagonal 0 and 0, 0, 0. So actually here it will be 0. Actually also you will see in the exercise, the product of unit lower matrices. Again, it is a unit lower matrix. And here it is unit also. Here all these units are 1. And how about here? Here we will have, it is 2. And here we will have, what is it? Here we will have -1. And here we will have -1. Okay. And also soon, actually, in easy way, you will see that if you notice here in lower part, here we have 2, 1 entry 2, right? If you look at this one, this 2, 1 entry, that's here we have just multiplied by -1 and the substitute here. It is 2, 1. And how about this one? This one is 3, 1 entry. 3, 1 entry in front of this one. Here we have 1 multiplied by -1 and right here. And how about this thing? It is 3 and the 2 multiplies by -1. Here we have -2. Actually, it should be -2. Okay. So now I can just write here that A is equal to L times U, where U is equal to this matrix, and this one is our L. This is how actually factorize A, or that is how to find the LU factorization of A. Okay. So unit lower triangular matrix. We have just talked about this. Actually, it looks like this L. All the entries in the main diagonal, they are 1s, and all the entries above the main diagonal, they are 0s, and below the main diagonal, it is 2, 1, and 3, 1, and 3, 2. And how about upper triangular matrix? We are not using unit here because the entries in the main diagonal, they don't have to be 1s. So all the entries below the main diagonal, they are 0s, and above the main diagonal, they are at least, they are not 0, not all actually equal to 0. So another one example here, we are given 4 by 4 matrix. That is how actually we write this A as L times U. Okay. So find the LU factorization of the given matrices. Okay, here we are given A and B. Maybe I should just keep it here, maybe. Much better. Okay. All right. Let's just try to do A and B. Here we have, let's use green now. So A, 2, 1, 1. All right. I'll put on my glasses. Okay. So here we have 2, 1, 1, 4, 3, 3, 8, 7, 9. Okay. So first we'll obtain U. To do this one, the first one is I should multiply the first one by -2, right? -2 times R1. -2 and add it to the second row. So here we will have 2, 1, 1. -4 plus 4, it is 0. -2 plus 3, it is 1. And -2 plus 3, it is 1. And after that, we should actually multiply the first row by -4 and add to 8. So here we'll have R3 minus, here we have 4 times R1. -4 times 2, -8 plus 8, that's equal to 0. -4 plus 7, that's equal to 3. -4 plus 9, that's equal to 5. Okay, now we have one more 3 here. To do this one, I should just multiply R3, second row by -3 and add it to the third row. So here we have 2, 1, 1, 0, 1, 1, and 0, 0, -3 plus 5, that's equal to 2. So that is our U. Okay. Now that thing actually, again, I can just write it as here. What is it? It will be minus, so it is minus. Okay, that is minus. All right. So here, when we have minus, 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 2, 1, actually. This 2 gives us L21 entry of, what is it? L. So that is L. That is one easy way to find this. We know that unit lower triangle matrix will be here something like this: 1, 0, 0. Here we have 1, 0. Here we have 1. And here we have two, what is it? L21 entry, right? And here we have 2, that is 1. So here we have minus. So that thing gives us that L21 entry. So that one is 2. And how about this one? 3, 1 entry. This one is 3, 1 entry. So here we have minus here. Just ignore the minus sign. So it is 4. And how about this thing? That is 3, 2. That one is 3, 2 entry. So here we have 3. Then this A will be equal to LU, where L is this matrix 1, 0, 0, 1, 0. We have 1, 2, 4, 3. And the upper triangular matrix will be 2, 1, 1, 0, 0, 0, 1, 1, and 2. Okay. So in similar way, also you can do this B. I will skip this for you. So now definition, let's just actually give a special name to this. Let A be a square matrix. A factorization of A as A equals L times U, where L is unit lower triangular matrix and U is upper triangular matrix, is called an LU factorization of A. As I told you, a lot of softwares, they have built-in function. For example, MATLAB, if you just write LU, okay, and give a matrix, it gives us LU factorization of A. Immediately we'll see that actually the question comes. It is unique or not. So now we will answer the question soon. So if A is a square matrix that can be reduced to row echelon form without using any row interchange, then A has an LU factorization. So if A is a square matrix, okay, that can be reduced to row echelon form without using any row interchange. You see here, when we are doing this, we didn't use any row interchange. So we didn't interchange any, what is it? Row interchange. If it is so, then always it is possible to find the LU factorization of A. All right, using the LU factorization of A, solve AX equals B. Okay, so that is now we are going to manipulate this method to solve this question, to solve this equation. And we know that in some different ways we can solve the system, right? And using LU factorization, how will we do this stuff? Especially in a lot of works, actually, they use this IDM when we have very big matrices, and also the algorithm for this is quite easy. And let's practice a few questions, and after that you'll have some intuition about this concept. So now the main idea is, let's start this. First, using the LU factorization, we have to write or find the LU factorization of A. And we know how to find this. So first step is here, our first step, A is equal to, here we have 2, 1, 3, 2, 1, 3, 4 minus 1, 3, negative 2, 5, 5. Right? Okay. Here we have the first one is R2 minus 2, R1. So here we have 2, 1, 3. Negative 2 times 2, it is negative 4 plus 4, that's equal to 0. Negative 2 times 1, negative 2 plus negative 1, that is negative 3. Negative 3 times negative 3 times negative 2, negative 6 plus 3, negative 3. And the second one is, okay, now we have 0. So it is 2, negative 1. Just we need to add the first row to the third row. So 2 plus negative 2, it is 0. 1 plus 5, it is 6. 3 plus 5, that's equal to 8. And the last one is R3 plus 2 times R2. So then we will have here, okay, the first row remains unchanged, 2, 1, 3. And also the second row remains unchanged. Here we have 0, negative 3, 3. And if you multiply by 2 and add to the third row, here we have 0, negative 6 plus 8, that's equal to 2. So which is equal to U. Now to find L, and see here, okay, we have no problem here. This one I can write it as R3 minus 1 R1, and this one is R3 minus 2 R2. So at the time this lower unit low triangle matrix will be 1 0 0 1 0 1. Here we have 2 1 entry, 2 1 entry. Here the coefficient is 2, so this will be 2. And how about 3 1 entry? Here we have negative 1, so that is negative 1. And 3 2 entry, here we have negative 2, and here we have negative 2. Make sure that it's always, it must be minus here, minus minus minus, and these coefficients will give us the corresponding entries of this matrix. Okay, now what we have here? Here we have, instead of A, I can just write this A x is equal to B, right? So we can write it as now L times U x, that's equal to B. Okay, so let me just denote this U x by Y. So let's say Y equals U times X. Now what we have here, instead of Ux, if I write Y, so I have here Ly is equal to B. So what we have here, let me just continue from here. Okay. All right, let's change the color. So we need to solve this problem now. So what we have here we have like this, right? L, we know this L here. So here L, Y means 1, 0, 0, 2, 1, 0, negative 1, negative 2, 1. And here we have Y. This Y vector is Y1, Y2, Y3. On the right-hand side, we have B, and B is here. What is it? 2, 7, 11. Right? Okay. So now, as you see here, by forward substitution, we can solve this. If you just write the system, right? So what we have here? Here we have y1 is equal to 2, right? The first row. If you multiply by the second row, here we have 2y1 plus y2 is equal to 7. And the last one, negative y1 minus 2y2 plus y3 is equal to 11, right? So from here, we know y1. So from here, what is y2? Y2 equals 2 times 2, it is 4. 7 minus 4, that's equal to 3. And how about here? This y3 equals 11 plus y1, which is equal to 2, plus 2 times y2, that's equal to 3. That's 13. 13 plus 6, that's equal to 19. So now we got y. What is y? Y is y1, y2, y3. That's 2 and 3 and 90. Right? Okay. So that is the second part. And now using this one, we should find x, because here we need to find x, right? Now if I substitute here, ux equals y. So here we have ux is equal to y. Now here we have just something here, right? And here we have y. We know y. So I will continue here. Okay. Okay. So here we have ux equals y, right? Here we have ux is equal to y. That is our third step. And we know what is u. U is that thing. It is 2, 1, 3, right? If this u is 2, 1, 3, this one is 0, this one is 0, okay? And the minus 3, 2. So here we have minus 3, 2, 0. And how about this x vector? That is x1, x2, and x3. And also we know the value of y, that is 2, 3, 19. So here we have 2, 3, 19. Okay, I don't like this color. So now by back substitution, now we can find the value of x1, right? As see here from the last one, I can get the x3 and then after the x2 and after the x1. Let's just write our system first. Here we have 2x1 plus x2 plus 3x3 is equal to 2. And here we have minus 3x2 minus 3x3, that's equal to 3. And from the last one, 2x3, that's equal to 19, right? So from here, x3 is equal to 19 over 2, all right? And how about here? If we just divide both sides by 3, right? And x2 plus x3 equals negative 1. So what is x2? X2 equals negative 1 minus, okay, here we have plus, okay, now it is minus x2. X2 is 19 over 2, which is equal to minus 21 over 2. So now if we substitute in the last one, then we'll get x3. So x1. x1 equals 1 over 2, and here we have 2 minus x2 minus 3x3, which is equal to 1 over 2. 2 minus x2 is 21 over 2 minus 3 times x3 is 19 over 2. So let's just calculate this quickly. Here we have 0.5 times and the 2 plus 11.5 minus 1.5 times 19. That's equal to minus 15 over 2. So now we can just write the solution of the system. Then the solution of the system is, that is x1, x2, x3, which is x1 is negative 15 over 2, x2 is minus 21 over 2, x3 is 19 over 2. Okay, that is how we solve a system using LU factorization. Okay, an easy way to find factorization, actually I have already shown this because we are not using any row interchange here, right? If we actually, I would say, can change this into U, applying a bunch of elementary row operations, because first you have to create zeros under this 3. This one is pivot, so this one is 2, 1, and this one is 3, 1, and this one is 3, 2. And next step is using this pivot, you need to create zeros under this, and after using this one, you should create zeros under this. So assume that the first one is, we will have something like this. Here we will have R2 minus, let's say this K1 times R1. And here we have the second one is, will be R3, because now I need to create this one 0. So it is minus, let's say K2 times R1. And now I need to create 0 here. So the third one is actually this is R2, R3, now R4 minus K3 and times R1. Right, now here we have zeros here. Now how about here? The second one will be the number 4. You will have here R, because R2, R3, minus K5 R2. And number 5, now we got 0 here. How about here? That is R4 minus K6 R2. And after that, now here we have zeros, right? And here we have zeros. Now this we should make this one is 0. So how can we do that? That's number 6. So that is R4 minus K7. And here we have R3. Now, as see here, actually all our minuses here. Minus here. So actually this 2, 1, actually that is L21 entry, 21 entry, that's equal to K1. And that's L31 entry, 31 entry, that's equal to, here we have K2. And that is L41, that is 41 entry, that's equal to K3. And this one here we have L32, here we have 32, that's equal to K5. And this one is L42, 42, that's equal to K6. And this one is 43, L43, that's equal to K7. Okay, that is an easy way to find LU factorization of a given matrix. So again, if you just back to this thing, for example, let's say you want to zeros here, right? What is L21? L21 is K1, right? How can I actually have zeros here? So to get zeros here, for example, here, let me just write here. That thing is, first one is, actually we should multiply the first row by -3 and add here. So here we have R2 minus 2 times R1, right? Just right here like this, because I have this. So if you do so, here we will have 3, 1, 3, -4, and the -3, here we have 0, -2 plus 4, it is 2, -6 plus 8, that is 2, it is 8 plus -10, it is -2. Next one is, second one is, we should multiply the first one by -1 and add here. So there's R3 minus R1. So -3 plus 3, it is 0. -1 plus 2, it is 1. -3 plus 5, that is 2. And it is 4. It's just 4 plus -1, it is 3. Next one is R4 plus 3 times R3. Right? So 3 times 3 plus -9, it is 0. 3 plus 5, it is 8. 3 plus 3, 9. 9 plus -2, it is 7. And -12 plus -4, that is -16. Now we have created zeros here under this 3. Second one is actually in this way, we need to create zeros under this 2. As you see here, we are not making any row interchange here. So here we will have number 4 is, what is this? R3, right? R3 minus 1 over 2 R2. That here we will have here, the first row is 3, 1, 3 minus 4, 0, 2, 2 minus 2. And here we have 0, 0. And here we have 0 minus 2 minus half, that's -1 plus 2, that's equal to 1. And here we have -12, that's equal to 1. 1 plus 3, that's equal to 4. And here we have 8. Okay. And how about this 8? That is number 5, R4, right? Actually, R4 minus 4 times R2. So that is -8 plus 8, that's 0. -8 plus 7, -1. And what is it? 8 plus -16, it is 8 plus -16 is -8. Okay. And the last one is, as you see here, I should just add this one, that's number 6, R4 plus R3. So here we will have here the same thing, right? The same thing, the same thing, the same thing. So here we have 0, 0, 0, and 4 plus -8, that is -4. Okay. Now I can just write the lower triangular matrix. Here we have 1, 0, 0, 0, 1, 0, 0, 1, 0. Here we have 1, 2, 1, and here we have 2. Here we have 1. Here we have minus 3, and here we have 1 over 2, and here we have 4. Here we have minus 1. Okay, and next session will continue after 10 minutes. Enjoy your break.